All right, engineering students, gather around. Today I'm breaking down orthogonal machining, an essential concept in the world of manufacturing. So what exactly is orthogonal machining? It's a simplified 2D model used to study the mechanics of cutting and material removal. Imagine this: the cutting edge is perfectly straight and perpendicular to the cutting direction. It extends the entire width of the workpiece, making it super convenient for theoretical analysis. Now, let's talk about the key features. First up, simplified assumptions. In orthogonal machining, we assume the cutting edge is perfectly straight and perpendicular to the cutting velocity. The workpiece material behaves uniformly and undergoes plastic deformation. The chip slides along the rake face with no lateral flow, meaning no side cutting. And cutting occurs in a plane strain condition, which is basically a 2D representation. Next, the mechanics. Material ahead of the tool gets compressed and sheared along a shear plane, transforming into a chip. The cutting forces, chip flow, and other parameters are simplified for analysis in 2 dimensions. Finally, let's break down the key component. You've got the cutting edge, the workpiece, and the chip. The cutting edge does the heavy lifting, slicing through the workpiece material. The workpiece, well, that's your material being cut. And the chip? It's the material that's removed during the cutting process. So there you have it. Orthogonal machining in a nutshell. It's a fundamental concept that helps us understand the mechanics of cutting and material removal. Keep this in mind as you dive deeper into your studies and future projects. If you found this useful, hit that like button and subscribe for more engineering tips and tricks. See you next time, and happy machining.